Now, batteries can't replace diesel, but new technologies with ammonia are emerging, and big money is pouring into the startups at the helm.
For years, scientists and inventors have toyed with the idea of a water-powered engine, but they often faced daunting obstacles along the way. However, Elon Musk, renowned for his trailblazing work in technology, has brought forth an intriguing perspective. His recent revelation could potentially shake up the entire transportation industry. This has sparked a wave of curiosity, with people pondering whether water could truly serve as a feasible fuel source and what other inventive solutions might exist to tackle transportation challenges. Let's delve into how Elon Musk unveiled the game-changing new engine and explore the implications of his announcement. Elon Musk surprises with new energy source. Elon Musk has astonished his followers on X, formerly known as Twitter, with a bold shift in Tesla's trajectory. Despite years of skepticism, Musk declared in 2024 that Tesla would transition from batteries to hydrogen power. This unexpected pivot was underscored by his announcement that the inaugural vehicle utilizing this fresh fuel source would be dubbed the Model H. This decision came as a shock, especially considering Musk's previous dismissal of hydrogen fuel cells as fool cells and labeling the technology as mind-bogglingly stupid. However, he has now made a complete about-face. The move is attributed to the challenges associated with mass-producing the 4,600 kWh battery, prompting the company to reassess its strategy and embrace hydrogen power. It's been demonstrated that water, much like carbon dioxide, can't serve as a fuel on its own. Both are byproducts of combustion, and converting them into usable fuels or energy carriers demands additional energy input. This is where the laws of thermodynamics come into play. They stipulate that the energy required to produce a fuel will inevitably exceed the energy obtained from using that fuel. Hence, instead of water, hydrogen fuel is being explored. Since its inception in 2003, Tesla, led by Elon Musk, has emerged as a global leader in electric vehicles. Musk, committed to elevating living standards through innovative technology while prioritizing environmental sustainability, has propelled Tesla to the forefront of the renewable energy and transportation revolution. He invests in various eco-friendly initiatives and leverages his platforms to advocate for change, aiming to reshape perceptions about energy, fuel, and climate change. Amid a growing global push for cleaner energy solutions to combat climate change, electric vehicles, spearheaded by Tesla, are gaining traction. How will the public respond to Tesla's announcement about integrating hydrogen fuel cells? And how might this new energy source revolutionize the driving experience? Let's delve into the details of this revelation. Vehicles, notorious for their significant contribution to climate change through fuel combustion, are witnessing a transformative alternative in electric cars. Tesla, Musk's multi-billion-dollar automotive titan, churns out 500,000 electric vehicles annually, significantly bolstering societal acceptance of electric cars. These vehicles primarily rely on batteries for power, akin to those found in laptops, but on a larger scale. These batteries store electricity acquired from either the grid or charging stations. However, issues such as prolonged charging times, range anxiety, and steep costs have discouraged consumers. In response, hydrogen fuel cells have emerged as a promising alternative. Despite Elon Musk's previous doubts regarding hydrogen technology, fuel cells have garnered attention within the automotive industry. But what exactly is a hydrogen fuel cell, and how does it operate? Strategically positioned among a vehicle's components, the fuel cell works in conjunction with a battery electric engine and a hydrogen tank to generate energy. Multiple fuel cells operate simultaneously through a process known as reverse electrolysis, where hydrogen reacts with oxygen to produce electrical energy. Unlike conventional electric vehicle batteries, fuel cell batteries are smaller since they are continuously charged by the fuel cell. This process ensures a steady and ample supply of electricity, with water vapor being the harmless byproduct released into the atmosphere. The environmental impact of the byproducts depends on the quality of the hydrogen utilized, with renewable energy sources producing hydrogen with a carbon-neutral footprint. Despite prevailing public perceptions, scientists are optimistic about the potential of hydrogen fuel cell technology and anticipate its advancement in the years to come. Benefits of hydrogen cell technology. In addition to the environmental advantages of fuel cell electric vehicles, they also offer distinct benefits in the driving experience. One notable distinction is the quietness of electric vehicles, devoid of the mechanical noises associated with traditional cars. Another significant factor is the charging time, which sets battery electric vehicles and hydrogen fuel cell cars apart. While battery electric cars often necessitate several hours for a full charge, hydrogen fuel cars can hit the road almost instantly once their hydrogen tanks are filled. This, coupled with the energy output of a hydrogen tank, grants fuel cell cars a broader range compared to their electric counterparts. Scheduled for release in 2024 is Tesla's Model H, which will showcase this innovative hydrogen fuel technology. The Model H boasts impressive specifications, including an astonishing acceleration from 0 to 60 miles per hour in just 1.2 seconds and a range of 450 kilometers. An automotive designer's rendering delves into the technical aspects of the Model H, highlighting its unique powertrain. Equipped with 6 electric motors, this powertrain dynamically distributes power, with 2 motors driving the front wheels and 4 propelling the rear wheels. This setup not only enhances performance, but also improves traction and stability. Beneath its sleek exterior lies a sophisticated energy system. The Model H prioritizes aerodynamics for efficiency, featuring a full-length floor diffuser that guides airflow along the car's floor, generating significant downforce crucial for stability and control, particularly at higher speeds. Additionally, the front vents are equipped with concealed flaps, enabling versatile airflow management. This innovative design element offers flexibility in controlling airflow direction, enhancing both performance and efficiency. Despite the current higher cost of hydrogen fuel cars, due to their rarity and the limited availability of hydrogen stations, industry experts anticipate changes in the next decade with advancements like those seen in the Model H. The growing urgency to address climate change has prompted more automobile companies to embrace cleaner technologies. Upcoming models like the Model 2 and Model Z, set to debut in 2025 and 2027 respectively, are anticipated to be supercars, signaling a notable shift towards hydrogen fuel cells in the automotive realm. Exploring the use of hydrogen fuel in various modes of transportation. Let's delve into Elon Musk's perspective regarding hydrogen as a fuel source. Musk, known for his outspoken opinions, has long expressed skepticism towards hydrogen fuel cells. He has pointed out the challenges associated with producing, storing, and using hydrogen in vehicles, underscoring the technological advantages of existing battery technologies. However, the automotive industry is diverse, and not everyone shares Musk's viewpoint. Major players like Toyota and Hyundai have made significant investments in the development and production of hydrogen fuel cell vehicles. Meanwhile, smaller manufacturers such as Riversimple are actively involved in creating hydrogen-powered cars. Beyond manufacturing, influential figures in the industry, such as Herbert Diess, CEO of the Volkswagen Group, have raised doubts about the practicality of hydrogen in the automotive sector. Diess argues that green hydrogen, produced using renewable energy sources, may be better suited for heavy industries like steel and chemicals due to its high cost, inefficiency, slow production, and logistical challenges. Despite Musk's steadfast stance, he has not publicly indicated any change in his perspective on hydrogen. The ongoing debate surrounding the future of transportation and the role of hydrogen reflects broader discussions on how to power vehicles more sustainably. This conversation involves grasping the fundamental differences between traditional battery electric vehicles and those powered by hydrogen fuel cells, as outlined by the US Environmental Protection Agency, EPA. Hydrogen fuel cell vehicles share similarities with electric vehicles but generate electricity on board by combining hydrogen gas with oxygen, adding another dimension to the evolving narrative of the automotive industry. In June, the BMW Group initiated tests for vehicles featuring a hydrogen fuel cell drivetrain, highlighting its potential to complement internal combustion engines, plug-in hybrid systems, and battery electric vehicles. Despite the increasing interest in hydrogen, especially for fuel cell electric vehicles, it's important to recognize that these technologies have yet to dominate the market. However, companies like Riversimple are actively developing hydrogen-powered cars and offering them on a subscription basis, though such vehicles currently make up a small portion of overall car sales. Toyota, a key advocate for hydrogen technology, envisions its applications extending beyond automobiles to various settings such as heating, lighting, large-scale mass transit, and heavy industry. The Fuel Cell and Hydrogen Energy Association emphasizes the zero-emission benefits, long-range capabilities, quick refueling, and scalability of fuel cell electric vehicles and hydrogen energy in the pursuit of low and zero-emission transportation. Expanding the discussion beyond passenger vehicles, larger forms of transportation like trucks, buses, trains, and planes are increasingly being considered for integration with hydrogen fuel cells. Daimler Truck's CEO, Martin Dahm, advocates for a balanced approach to this development, recognizing the suitability of different technologies for specific scenarios. While battery electric vehicles excel in city deliveries with lower energy requirements, long-distance transportation scenarios may benefit from the practicality of hydrogen fuel cells. This versatility is evident across various sectors beyond automobiles. European transport leader Alstom has introduced the Coradia iLint, touted as the world's first passenger train powered by a hydrogen fuel cell. In aviation, plans for commercial hydrogen electric flights have been announced, with aspirations to take flight in 2024. Even the construction industry, represented by major players like JCB, is not lagging behind, with the development of a 20-ton excavator powered by a hydrogen fuel cell. Despite the enthusiasm surrounding the potential applications of hydrogen fuel cell technology, the journey to mass adoption faces significant challenges. Honda's recent decision to cease production of its Clarity plug-in hybrid and fuel cell models earlier this year underscores challenges related to durability, reliability, and vehicle cost. The US government points to infrastructure limitations as a major hurdle, expressing concerns about the current inadequacy of infrastructure to support widespread adoption of fuel cell vehicles. The competitive landscape adds further complexity to the trajectory of hydrogen in the transportation sector. Green hydrogen, generated from renewable sources, not only competes with traditional fossil fuel-based hydrogen, but also contends with other conventional fuels like petrol, diesel, and electricity. The challenges outlined in the International Energy Agency's Global EV Outlook 2021 highlight the existing disparity in registrations between fuel cell electric vehicles and traditional electric vehicles, primarily due to the limited availability of hydrogen refueling stations. Conversations, particularly on platforms like Twitter, have emerged regarding Elon Musk's shift towards hydrogen technology. Critics express skepticism due to Musk's previous dismissal of hydrogen-fueled vehicles, raising questions about his motivations and the industry's direction. However, discussions have also explored Musk's potential next move, with speculation about an ammonia engine. The distinct properties of ammonia, a hydrogen compound with higher energy density than hydrogen gas, offer possibilities for greater range compared to traditional combustion engines without the emissions associated with gasoline or diesel. Ammonia can be sustainably produced from renewable sources, adding an environmental sustainability aspect to the fuel. In a pioneering development for passenger cars, GAC, a Chinese state-owned manufacturer, has partnered with Toyota to develop a new combustion engine fueled by ammonia, marking a significant milestone in the automotive industry. The 2.0-litre four-cylinder engine, crafted by GAC, flaunts 161 horsepower, exemplifying ammonia's potential as an alternative fuel source. MAN Energy Solutions is embarking on an ambitious endeavour to develop a two-stroke ammonia engine for large-scale container ships by 2024, with plans to introduce a retrofit package for existing ships to utilise ammonia a year later. The maritime industry is actively pursuing greener shipping initiatives in response to the significant environmental impact of maritime shipping, which contributes approximately 940 million tonnes of carbon dioxide annually, accounting for roughly 2.5% of all greenhouse gas emissions. The International Maritime Organization, IMO, has acknowledged the urgent need for mitigation measures, foreseeing a potential 50% increase in ship emissions over the next 3 decades. To counter this trend, the IMO has mandated a 70% reduction in emissions from ships by 2050, with a long-term goal of phasing them out entirely within this century, compelling many in the maritime sector to take action. Ammonia emerges as a promising alternative, offering undeniable advantages that could contribute to a sustainable maritime shipping industry. It can be produced from air and sunlight, presenting a carbon-free option. Moreover, its utilization builds upon established technologies and infrastructure, expediting the path to sustainability. However, transitioning to ammonia-powered engines necessitates time for capacity building and retrofitting ships' two-stroke engines to accommodate this innovative fuel. Jeppe Ostergaard Sorensen, a representative from MAN Energy Solutions, acknowledges the significant interest from shipping companies in adopting new fuel technologies. Collaborations are already underway, underscoring the industry's commitment to greener practices. However, the economic feasibility of such transitions remains a critical consideration. Ostergaard Sorensen stresses the importance of flexible solutions that facilitate a gradual transition, ensuring that no shipping company risks having its fleet stranded during this transformative process. While significant advancements are underway at the Research Centre Copenhagen, where the two-stroke ammonia engine is undergoing construction and testing, MAN Energy Solutions is not working in isolation. The Maersk McKinney-Moller Centre for Zero Carbon Shipping, a non-profit research and development centre, plays a crucial role in this transformation, with MAN Energy Solutions serving as a co-founder. Maritime engineers are deeply immersed in this formidable task, aligning with the broader goal of transitioning the shipping industry into a sustainable enterprise. Despite the progress, there's a palpable sense of urgency, with Ostergaard Sorensen stressing the imperative for immediate action to meet IMO objectives. However, alongside optimism, there's also skepticism regarding the future predominance of ammonia. Concerns linger regarding infrastructure readiness, safety protocols, potential accidents, and the energy-intensive nature of the production process. The development of ammonia fuel engines presents its share of challenges. Researchers have identified issues such as low combustion efficiency and high N2O emissions associated with these engines. The inefficient combustion and elevated N2O emissions stem from ammonia fuel's poor combustion characteristics. Substituting diesel with ammonia reduces combustion capacity, leading to decreased efficiency, while incomplete combustion of ammonia fuel results in N2O emissions. To enhance ammonia's combustion capability, researchers have explored various methods. One promising approach involves using highly active fuels mixed with ammonia. Hydrogen and methanol have been proposed as accelerants to enhance ammonia's combustion capability. Studies by Chen, Li, and Nadiri have investigated the impact of hydrogen and methanol on ammonia combustion, yielding encouraging findings. For example, adding 5% methanol was observed to significantly reduce the ignition delay period of ammonia combustion by 60%, demonstrating the potential of these additives in enhancing combustion efficiency. Furthermore, the utilization of ammonia in conjunction with highly active fuels like hydrogen and methanol has been demonstrated to enhance the engine's combustion efficiency, consequently reducing the emission of N2O. The incorporation of hydrogen and methanol as accelerants in ammonia fuel engines offers a promising avenue for addressing the identified challenges and optimizing the performance of these engines. Exploring other technological breakthroughs. Elon Musk, the visionary entrepreneur, continues to peer into the future as he introduces Neuralink, a venture aimed at unraveling the mysteries of the human brain. Musk envisions a world where a significant portion of human intelligence resides in the digital realm, leading to new frontiers in understanding cognition. While discussions about transportation often revolve around battery electric vehicles, Musk's focus also extends to advancing neuroscience and tackling brain and spinal cord issues. Neuralink strives to revolutionize the treatment of neural disorders, aiming not just to treat them, but fundamentally transform how we approach brain and spinal injuries. Musk emphasizes Neuralink's objective of developing a seamlessly implanted device, a whole brain interface capable of interacting with every aspect of the human brain in the long term. This mission is ambitious, envisioning a future where brain-related problems can be addressed through discreetly implanted devices seamlessly integrated into daily life. Musk paints a vision of a future where Neuralink's advancements could facilitate the transfer of human cognitive abilities into the digital realm. He acknowledges that the journey towards advanced Neuralinks will be gradual, possibly preceded by the arrival of artificial general intelligence or digital superintelligence. He even envisages a scenario where human cognitive abilities merge with artificial intelligence, potentially mitigating challenges associated with rapid technological advancement. In the short term, Neuralink aims to focus on solving brain and spinal injuries, aiding individuals who have lost the use of their limbs or suffered traumatic brain injuries. While Musk recognizes the significance of his other projects, he hints at Neuralink potentially being the most pivotal, especially considering its long-term implications. The idea of downloading human brain capacity into a digital Optimus, as envisioned by Musk, is both captivating and speculative. While the current focus of the device is on addressing immediate challenges related to brain injuries, the long-term aspiration of merging human intelligence with artificial intelligence through advanced brain interfaces is a concept that will gradually unfold over time. Musk introduced the notion that we are already, in a sense, cyborgs. He emphasizes how our phones and computers have become extensions of ourselves, seamlessly integrated into our daily lives. The feeling of missing limb syndrome when separated from our phones underscores the deep integration of technology into our existence. Musk envisions a future where this integration goes even further, extending beyond our external devices to create a more direct interface with our brains. Describing neurons as the wiring of the brain, Musk highlights the necessity of electronic solutions to tackle the intricate challenges posed by neural malfunctions. The work being done at Neuralink holds the promise of illuminating how the brain and mind function, addressing the current limitations in our understanding of brain functioning. Musk compares existing methods, such as fMRI or functional magnetic resonance imaging, to merely putting a stethoscope on the outside of a factory wall. They provide some insights, but lack the precision needed to truly comprehend the inner workings of the brain. How Neuralink will transform the world. In his exploration of Neuralink, Musk underscores the paradox of the cerebral cortex, showcasing its superior intelligence while recognizing its role in appeasing the more primitive limbic system. The reality is that almost everyone will develop brain and spine problems over time. Musk emphasizes that implantable devices, like those developed by Neuralink, have the potential to address a wide range of neurological disorders. From memory loss to paralysis, depression to extreme pain, correcting the electrical signals sent by neurons can offer solutions to a myriad of issues. In addition to conventional safety standards, Musk emphasizes that Neuralink is pushing boundaries to ensure a level of safety that surpasses even the most stringent regulatory requirements. He elaborates on how a neural device can significantly enhance bandwidth, fostering a more symbiotic relationship between individuals and the AI extensions of themselves. Musk highlights the human brain's division into two parts: the primitive limbic system and the cortex responsible for higher-level thinking. Despite the cortex's superior intelligence, its primary role often revolves around satisfying the limbic system. The overarching goal of Neuralink is to achieve unprecedented neural restoration, aiming to restore functionality to individuals who have lost full connection between their brain and body. Contrary to common misconceptions, working at Neuralink doesn't necessitate an extensive background in biology. The required skills are akin to those needed for developing modern gadgets like smartwatches or phones, covering software, batteries, radios, inductive charging, along with expertise in areas such as animal care, clinical matters, and regulatory compliance. Elon Musk stresses Neuralink's transformative potential, asserting its capability to empower individuals with limited or no mobility to manipulate technology more efficiently than those with fully functioning limbs. He emphasizes the commitment to rigorously following FDA approvals, ensuring compliance with safety standards well beyond regulatory requirements. Initial Neuralink devices will focus on restoring basic functionality to individuals who have lost connection between the brain and body, particularly quadriplegics and tetraplegics. The first application targets restoring communication speed and efficiency for individuals like Stephen Hawking, who faced communication challenges due to physical limitations. Musk envisions a future where quadriplegics and tetraplegics can regain swift communication abilities through Neuralink, highlighting the potential for groundbreaking advancements in enhancing the quality of life for individuals with physical disabilities. In Neuralink's ambitious roadmap, the second application involves restoring eyesight. Musk explains how, even in cases of complete blindness or optic nerve damage, Neuralink can directly stimulate neurons in the visual cortex, potentially restoring vision. Additionally, the technology could enable individuals to perceive different wavelengths, offering enhanced vision capabilities akin to sci-fi concepts like seeing in ultraviolet or infrared. With a crescendo of promise, Musk portrays the device's potential not only to heal, but also to enhance human capabilities beyond current understanding. Neuralink's applications extend to addressing various brain-related issues, from spinal injuries to diseases affecting the brain-body connection. Musk is confident that Neuralink can empower individuals with severe physical limitations to operate electronic devices more efficiently than those with fully functioning hands. As neurotechnology advances, Neuralink leads the way, merging technology with neurobiology to create groundbreaking solutions that have the potential to redefine possibilities for individuals facing neurological challenges. The journey towards unprecedented neural restoration has begun, with Neuralink pioneering a future where technology seamlessly integrates with the human mind, opening new avenues for communication, mobility, and sensory experiences. Thank you for watching. Don't forget to subscribe to the channel and explore another one of our intriguing videos before you go. See you on the other side.